All right, everybody, let's do this. Little intro to what you just explored a little bit on your inquiry lab. Let's take a look at concentration, molarity, and dilution. So when we talk about concentration, what we're trying to explain is how much of the solute is dissolved in a certain amount of a solution. The solute is what's being dissolved. Think about a Kool-Aid mixture. The water that you put in the picture is your solvent. It's what does the dissolving. The solute would be the Kool-Aid mixture. That's the coloring and the flavoring and the sugar that you pour in. And once you start to stir that together, the Kool-Aid mix, the solids disappear into the liquid mixture. So the Kool-Aid is being dissolved. The water is doing the dissolving. I'll actually post a link in the same assignment that will show the process of dissolving. Water molecules have a positive end, which is a hydrogen end, and the negative end, which is the oxygen end. And when you have a solute particle that's floating around, those water molecules actually grab onto the solute, and then they will pull them apart out of the crystals. And when they pull those crystals apart, they then move those pieces throughout the solvent. So I, again, will put a link in the video or the description that will take you to a simulation of the dissolving process. All right. Conceptually, how are these things related? Okay. So if we have a solution and we want to increase its concentration, we want to get more stuff dissolved, we can do that two ways. We can add more solute. So if you want your Kool-Aid to taste stronger, you just add more mix. If you add too much mix and it's too sweet or it's too sour, if it's lemonade or something like that, and you want to decrease the concentration, you want to make it weaker, which is the process called dilution, you would add more water. So we can make a solution more concentrated by adding more solute or evaporating some of the liquid solvent out. We can make it weaker by adding more of the solvent. It's really hard to remove the solute, the Kool-Aid mix, after it's been dissolved. Once it's in there, it's really hard to get back out. So if you need to make it weaker, if you need to make the concentration less, you would have to add more solvent. As we study concentration, we're going to look at this calculation called molarity. Molarity is a unit of concentration, and it's defined as the moles of solute over the liters of solution. So if you need to calculate the molarity, and you know how much solute you have, and you know the volume of your solution that you want to make, you would take your solute, if it's given in grams, and you would convert that to moles. Take your volume in whatever unit it's given, cubic centimeters, milliliters, liters. Make sure that it's in liters. It has to be moles of solute over liters of solution. Plug those in, and then that'll give you the strength and molarity, the concentration. Let's go through an example problem of calculating molarity. So our problem would be something like this. What's the molarity? What's the strength of our solution if we dissolve 37.49 grams of potassium hydroxide in enough water to make 500 milliliters of solution? So we know we have to use the molarity calculation. We're looking for molarity, which is abbreviated with a big M. So we have to take our grams of potassium hydroxide, that's our solute, and we need to convert that to moles. So we're going to take our grams, and we're going to multiply that by 1 mole over 56.11 grams. We get this number from the chemical formula. 1 potassium, take its mass from the periodic table. 1 oxygen, take its mass from the table. And 1 hydrogen, take its mass from the periodic table. Add those all together, and you get 56.11 grams. The grams have to go on the bottom, so they cancel. Moles are on top because that's what we're trying to get. The next thing we need to do is we need to change our volume to liters. Remember, the conversion from milliliters to liters or cubic centimeters to liters is 1 to 1,000. There's 1 liter has 1,000 milliliters, or 1 liter has 1,000 cubic centimeters. Put the milliliters on the bottom so they cancel. We're left with liters. Now we have our two pieces, moles of solute, liters of solution. So we can plug that in to our equation. Moles of solute over liters of solution. And when we do that, the 0.6762 moles over the 0.50000 liters, divide that out, you get 1.352 moles of potassium hydroxide per liter of solution. We can write it out that way, 1.352 moles of KOH per liter of solution, or you can just put the big M after it and then whatever your solute is. Big M KOH means moles of KOH per liter of solution. All right. So now we're going to look at an example of how to find the mass of the solute to make a volume of a certain concentration of solution. You're given the volume of your solution and the strength of the solution. They want to know mass. If we look at our equation, nowhere in the equation is mass given, but moles is given. So if we rearrange this equation to find moles, we can convert moles to grams using molar mass. Let's take a look at this calculation. So this is our unknown. We're going to rearrange the equation, multiplying both sides by liters of solution. Liters of solution is going to cancel out on this side. We're going to end up with molarity times the volume. It's going to give us moles. Multiply out, or show the units as moles per liter for molarity. That way, these liters and these liters will cancel. You end up with moles, which is what you're looking for. Now, let's plug our numbers in. Molarity, moles per liter, 6.00 moles of NaOH per liter of solution. That's what the M here stands for. Moles of solute, sodium hydroxide, per liter of solution. Multiplied by our volume, 0.750 liters, and you can see your liters cancel. If you write out molarity as moles per liter, your liters cancel. And you end up with 4.50 moles of sodium hydroxide. We're almost there. Now we just need to multiply and get grams. So take the molar mass of sodium hydroxide, 22.99 plus 16 plus 1.01 from the periodic table. Set it up so that moles cancel. We're left with grams. We get 180 grams of sodium hydroxide. So how the heck would we make this solution? First, we'd mass out the 180 grams of our sodium hydroxide, and we'd put that in a container that could hold at least 750 milliliters. Then we would add some water to that container until we were at about maybe 700 milliliters. Mix that all together, stir it up until all the sodium hydroxide dissolved, and then finalize it by adding enough water that your total volume of solute and solvent together would be 750 milliliters. So you put the solute in first, you add your solvent, your water, to get about 80% of the volume. About 80% of 750 is around 700, ballpark. Stir it together, and then make sure at the very end, the solute and solvent together in the solution has a volume of 750 milliliters. Now, the last thing we're going to talk about, which may be the most relevant thing to you just in normal daily life, is this process called dilution. Dilution is the process of reducing the concentration of a solution. And we usually do that by adding more solvent to an existing sample. To figure out how much of the concentrate, the high molarity solution and water you need to mix together, we can use this equation. M1V1 equals M2V2. M1 is the original concentration. That's the molarity of the concentrate, the strong solution. V1 is the volume of the original solution, the concentrate that you need. M2 is the desired concentration of your weaker solution, what you're trying to get it watered down to. And V2 is the volume of the diluted solution at the end. So let's look at this problem. If I have a 500 milliliter sample of 2.4 molar KCl, and I want to water it down to make it a 1 molar KCl solution. I want to reduce the strength of it. I need to figure out how much water I need to add to that strong solution to make it a weaker concentration. So this is what we know. We know we need to use the M1V1 equals M2V2. We know our original strong concentration is 2.4 molar, and we have 500 milliliters of it. If I want to make it weaker, I want to make it 1 molar, 1 mole per liter KCl. I want to water it down. I need to find the volume I would need to change it to. So in this reaction, in this calculation, we're going to be looking for our new volume. We do that by dividing both sides by our final molarity, our M2. That gives us a new equation of M1V1 over M2. M1V1 over M2 gives me V2. Plug in what you know. We know we have 2.4 molar, 500 milliliters of it. We want to get 1 molar. Notice your molarities will cancel. If we multiply this out, we end up getting an answer of 1,200 milliliters. Now be careful. It asked how much water needs to be added. If we already have 500 milliliters and we need to get a final volume of 1,200 milliliters, we need to subtract the original volume from that 1,200. To get our original solution to 1,200 milliliters, we would have to add 700 milliliters to it. And the end result is that we would have 1,200 milliliters of the weaker 1 molar. So again, we used M1V1 equals M2V2. We solved for V2. We plugged in the original molarity and volume. We had 2.4 molar and 500 milliliters of it. We plugged in the volume we wanted to get, 1 molar, and that gave us 1,200 milliliters. If we add water to this to make the final volume 1,200 milliliters, we would have 1 molar. So to get that scenario, we would have to add 700 milliliters to what we already had to get a 1 molar solution. So anytime you're given a starting concentration and you're asked to find a new concentration, or you're given an amount of water that needs to be added. So they're asking you, you have this original solution. How do I change it to be a different solution? That's when you're going to have to use the M1 V1 equals M2 V2. That's the dilution equation. Anytime you're asked to find the amount of solute needed, or you're asked to find the molarity, or only 1 molarity is given in the problem, you're going to use the moles of solute over liters of solution. So at this point, you should be able to go back to the inquiry lab and work through simulation 2 along with the questions that are associated with it. After you finish that up, take the practice test and then complete the final Module 7 assessment. That'll be the end of the graded work for the quarter. Please make sure that those are done Friday or Monday. Make sure that everything that you want me to grade, if you're missing any work, anything that needs to be graded needs to be in my inbox or submitted to the Google Classroom, or your forms need to be submitted by 10 a.m. on June 5th. Make sure that your work is done, turned in. After that, it's a hard stop date that the district gave me. After 10 a.m., nothing will be accepted. No grades will go in after 10 a.m. on June 5th. I need to have my grades finalized by 3:30 that day. If you have any questions, please email me, post them in the class comments, help each other out. Finish strong, stay healthy, improve daily, and get after it.